What's going on, everybody? Oh man, here we are. It is 1:40 in the morning, but I am thriving right now. Having so many technical difficulties with uploading, and things are just nothing's working. So we're just going live stream. So hopefully you all are in bed. Hopefully no one's watching this. If you're watching this, shoo, save this for tomorrow, folks. Doing some steps there, okay, at the beginning, because I'm gonna be going through the steps of the nitrogen cycle for you. Okay, I know they can be a little bit confusing, but we're going to hopefully try and bring it to light. All right, so that's what we're going to try and do. So I was doing my step ups there. But all right, so let's talk about these steps. Okay, you guys had a little bit of an intro through for the folder earlier in the week. Okay, so hopefully you read through there. Hopefully some things are making sense, but I'm hoping just to kind of clear up the steps in general. Okay, so we have 5 different steps. So we'll go through those right now. We're going to start. We'll start with the first one. Okay, so nitrogen fixation. Okay. As the Science with Suszek video mentioned, hopefully you watched that earlier in the week. But remember, the big problem with the nitrogen cycle is not the lack of nitrogen. We have so much nitrogen readily available in the air, but the issue is usable. Okay, usable nitrogen. Okay, I think of it like the way that I think about it is nitrogen needs to get into the ground. It needs to get into the soil, but the ground is just not ready for it. Okay, it's like trying to give a baby a steak. Like, here you go, baby. It's a brand new newborn trying to feed it a steak. It's like, yeah, good luck, right? It needs baby food. It needs liquids. Okay, so that's the same way with the soil. It's not ready for this nitrogen in the form of the nitrogen gas N2. It needs to be changed. Okay, so let's talk about our first step: nitrogen fixation. All right, and I think we all like shortcuts, right? Shortcuts are always nice. Well, there's a shortcut way to make bacteria instantly ready. Boom. The nitrogen, or excuse me, if I said bacteria, to make the nitrogen readily available. And it's a little shortcut cheat method, but I got my good friend Lightning McQueen from the movie Cars, right? Because lightning is one way, okay, to make nitrogen usable right off of the bat. Okay, so lightning strikes and even fires, right? I know we had our Australian wildfires going on for the longest time. Okay, wildfires are good, right? They are natural, okay, and they are beneficial for soil. But again, some cases they get a little bit. Does more harm than good. But so fires. So think this intense heat, right? Fires and lightning strikes can instantly make the nitrogen in the air, boom, usable for the ground. It turns it into the form of this end product that we'll get to very soon. I don't want to spoil it. Okay, so lightning, fires, boom, the quick, easy shortcut. Okay, to make nitrogen easily usable. Okay, but there's other ways that nitrogen can get into the ground. Okay, it gets in through precipitation. Okay, so through rainwater or through snow, right? The rain is drizzling down. Okay, it attaches. Okay, it connects, hits these nitrogen, molecules. Boom, and they travel down into the ground together. Okay, and then also it's a sad way, but plants and animals, whenever they die, okay, their nitrogen goes back into the soil as well. So there's many different ways for nitrogen to get into the soil. But let's talk about nitrogen fixation. So that's part of nitrogen fixation. There, that shortcut cheat step. All right, but we also so the first part for our regular nitrogen that gets into the soil. Okay, so we have N2. Okay, this nitrogen, and it is going to be. Oh, it's not going to show up well. Okay, converted into this first form. Okay. NH4, it's going to be converted. So there's nitrogen bonded to 4 hydrogens, all right? And it is called ammonium, okay, ammonium. So that's what's kind of happening to this regular nitrogen that gets into the soil. Okay, I feel like I'm hiding. This regular nitrogen, the first part is going to be turned into ammonium, which is nitrogen bonded to 4 hydrogens, all right? So really that's That's what's happening. We're going to see there's going to be a lot of makeovers going on. There's these specialized bacteria, okay, different types. So I got my friends here, all right, my bacteria, and they all serve different roles, okay? So one of them, we can say, let's go bacteria A here, is responsible for making ammonium. Okay, they're all going to have different jobs. So ammonium, that's that first step, right? So there we go. We've changed it to ammonium, but guess what? Plants, they're picky, right? They're like, that's not good enough. I don't want your ammonium. Okay, I want something better. So that's where the other steps are going to come in here. Okay, ladies and gentlemen. So let's go to the next step. So we had nitrogen fixation. Okay, I guess I really didn't write it on the board for you here. But the second one, nitrification there. So this is step number 2. And really what's happening here, this is a big important step here, okay? Step 2. All right. What is it? First is the worst, second is the best, I guess. That's what they say. People that don't win, they say second's the best. But the second step, this might be the best one here. So a lot happening. I'm gonna get a different marker other than green. Let's get a black marker here. So what did we leave off with in the first step, right? We left off with NH4, right? Ammonium. Nitrogen bonded to 4 hydrogens. So we left off with ammonium, but this ammonium is going to get changed. Okay, so it's got to get a little makeover, got to get a little new outfit going on. Okay, so what's going to be made? Okay, what's going to be made is NO2, 1 nitrogen bonded to 2 oxygens. Okay, so they're called nitrites. This I here, so important. Nitrites. Okay, NO2, nitrogen bonded to 2 oxygens. Okay, and so we could say maybe that's bacteria B here. Okay, maybe he's the one who's responsible for taking ammonium and changing it up and making it nitrites. Okay, nitrites with the I. Now, we're not done yet in nitrification. There's still one more thing, all right, there's still another little transformation. Wow, I can't find my other whiteboard. This is fantastic. Here it is. These nitrites, remember NO2, all right, we're not done here. They are going to be converted to NO3, known as nitrates. Okay, so it's like, wow, literally the difference is 1 extra oxygen, okay, and the difference is an A instead of an I. But I'm gonna give us a way to try and remember those steps so that you don't mix them up. Okay, now folks, nitrates, that is what we need. That's what the plants want. That's the form of nitrogen that they are craving, right? So the plants right now, here's the my name is Josh Suszek. I'll be your waiter this afternoon, okay, or this evening, I guess, for this morning, since it's like 1:49 right now. All right. So we have some delicious specials going on today. We have the NH4, the ammonium. It is delicious. Okay, it's like a cream sauce and some wonderful spices. Okay, but the plants are like, no, don't want it. Yuck. Hey, okay, sorry, can't please everyone. Goodness gracious. Okay. Well, in addition, we have a wonderfully a super tender, aged for 48 hours. We have this NO2, these nitrites, and they are delicious. Okay, with a side of French fries. Okay, or a side of like a baked potato, sweet potato. These nitrites, but plants are like, yuck. All right. Here we go. Wait, I'm your waiter, okay? And I'm here to serve you, okay? But how about we have this? We got a really nice special going on right now. Let's just say the chef makes the best of this NO3 nitrates. Okay, it is a delicious dish. Okay, one of the most delicious, eloquent dishes in the whole world, I'd say. All right, nitrates. There we go. NO3, and the plants are like, you know what? Give me some of that. All right, I'll take. Give me that. Give me whatever you're serving there. Now, here's how we're going to remember that we need nitrates, okay? Because we got all these different terms here, right? So here's how I think about it, okay? Nitrates. I think nitrates, it's kind of like late, right? Nitrate, late. It's kind of like the last one to be made, okay? Nitrates, but also, all right? So it's NO3, okay? One nitrogen bonded to three oxygens. But look, if I flip the three, okay? If it looks like a letter, okay, it looks like a W, okay, and not for my SpongeBob fans, not W for Wumbo or Wumbology, okay, but looks like a W. So if I take this three, if I actually flipped it and made it a W, okay, if I just took the three and flipped it, look at this, spells now. Now we're talking, right? Now we're ready to go. The plants are like they're excited. Now that's what I want. Nitrates, right? So I hope that kind of helps you to remember that, hey, plants, they want nitrates, NO3, all right, because they want it now. Now that's what we're talking about, all right? So I hope that helps you. I really, I think that kind of helps. It's kind of something I thought of. So hopefully that sticks with you there, all right? So we're kind of leaving. Again, there's a whole bunch of, maybe we'll say our friend little c here, okay? Little c, he's the one who's responsible for making nitrates, okay? He takes the nitrites, all right, and adds on an oxygen. Boom. Now we go from nitrites to nitrates. And it is also night time. So hopefully everyone's like sleeping right now, because I should be sleeping. But so now we go on to the third step, okay? Assimilation. Okay. The third step. Now, again, we're in business now. We're doing okay because we have what we need, right? We have nitrates. That's what the plants want. So basically, we got what we want, right? So again, chef or server Suszek, right? I'm the waiter. Okay. Now this is like me bringing out the food for the plants, and the plants are like, all right, it's time to eat. Okay. And that's what's happening with assimilation. The plants are, they're absorbing, okay, this nitrogen. Okay. They're absorbing the nitrates, right, from the soil. And they're doing this through their roots. Okay. So the word actually assimilation is actually like the process of like taking in or like knowing something. It's the process of like kind of like learning. So if your assimilation is taking in information. And so we can think assimilation kind of with these plants here is taking in, it's not necessarily taking in information, but it's taking in food. Okay, so it's taking in those nitrates. Okay, so it's like again, so these roots are absorbing. All right, so I don't know why I'm like thinking of like hungry hippos right now. The little game, right? They're just kind of getting all those little all the little hippo pellets, whatever they were. But yeah, so they're absorbing it through their roots. Right? Now that's our third step, and now we got the fourth step. Okay, the core four, and this fourth step here, it's gonna maybe sound a little bit familiar to something prior. Uh-oh, I'm writing too big. I'm gonna have to squeeze in these last letters. Yikes, that was tight. All right, ammonification. Okay, almost like ammonium. Okay, remember what was made earlier in the first step, nitrogen fixation? That nitrogen was turned into ammonium. Remember NH4, one nitrogen bonded to four hydrogens. So what happens in ammonification? Basically, this is a sad part. Okay, but we're kind of leaving the plants here for a second, right? And they were eating taking in nitrates through their roots. But now, again, we have these animals and plants, and they have to die at some point. Okay, and so when these plants or these animals die, okay, what they're made of. Okay, it's not just nitrogen, but these other elements, especially like carbon. Okay, they're recycled. All right, so this nitrogen is taken. So this nitrogen that is in the animals. And by the way, so it gets there, okay? Because again, animals need nitrogen. We'll just do a little side note here. Animals need nitrogen, and so do we as humans. We need nitrogen for what we do on a daily. We just need that to survive. Remember, like in my video, even our our DNA is made up of nitrogenous base pairs: adenine, thymine, guanine, cytosine. Remember, apple in the tree, car in the garage. It's made up of of nitrogen. In addition to, we just need it for just to it's necessary for us, but we can only get it through eating plants or eating animals that have eaten plants. Okay, so that's the only way that we can get nitrogen. So so for this this ammonification, this step, what's happening is again, plants or animals die. Okay, and that nitrogen is recycled back into the soil. So the bacteria, okay, take the nitrogen, they convert it to ammonium, NH4. So now we kind of have to go back to, now we're back at phase one, right? We're at ammonium, and we're going, so it really actually circles back to, the second step, nitrification, right? Because that's where, remember, we start with ammonium, and then remember, that's where all those makeovers are happening, right? It's going to become nitrites, and then nitrates, right? Remember, because of our bacteria friends here. So that's where the cycle kind of, it loops back. It goes back to stage or step two. All right. So with this ammonification, very sad stuff when our good friends, the animals and plants, whenever they die. So that's ammonification there. Here's how I like to think of it, folks. Here's how you're going to remember it. Okay. Ammonification, I think, ammonification, right? Almost sounds like a big yawn. Ammonification. I know I kind of probably sounded like the whale in Finding Nemo there, but ammonification. There it is, folks. All right, yawning. It's like the plants, animals are taking a very, very, very long nap, forever. They're dying. Okay, so that's what you can think of there. So hopefully that helps you to remember as well. And ladies and gentlemen, we get to the last step here. Again, this is, I'm sorry for it's not the smoothest presentation, but we are trying the best we can. And I can't spell. Denitrification. Okay, denitrification, step 5. Okay, how I remember this is when there's just extra nitrogen available in the soil. It doesn't matter which form it's in. Okay, so if there's maybe an abundance of ammonium, or maybe there's nitrites or nitrates. If there's an abundance, okay, our little bacteria friends, what they do is they can strip. Okay, they can kind of do some some adding and some subtracting. Okay, they can strip these oxygens. Okay, bond another nitrogen, making N2, and this nitrogen is going to go back into the air. Okay, for the NH4, it can strip the hydrogens. Okay, rip them apart, okay, and add on another nitrogen. Right? So we have N2. All right, goes back into the atmosphere. So denitrification, I think I don't know. I think like see you later. Like it just kind of sounds, it kind of rhymes. Okay, denitrification. I'll you later. See you later. All right, that's kind of what I think of. That's kind of my way to remember. That's extra nitrogen. We grow up so fast. Why? Just stay at home. We love you, nitrogen. Nitrogen, we love you here at LVMS. I want you to know that. We love you here at LVMS and LVMS Online. We love you. All right. So nitrogen, thank you for what you do. Well, ladies and gentlemen, I think that's kind of the conclusion of this video here. I hope it helps you with regards to the steps of the nitrogen cycle. If you have any questions, I will be in my Zoom sessions, and I'm here to help you. So good luck. And I believe I'm probably missing something like super important that I wanted to say. I don't think so. Hopefully this made things clear for you guys. All right. And YouTube live stream, thanks for getting this in. So many technical difficulties, but it's done. All right. So hey guys, good luck here.